Thank you for taking your time to watch this video. In this video, I would like to introduce my work, Improve Knowledge Transfer for Semi-Supervised Domain Adaptation via Trico Training Strategy. So first of all, I would like to briefly summarize the setting in Semi-Supervised Domain Adaptation. In the Semi-Supervised Domain Adaptation, we are given the rich label source sample and a few label target sample with large unlabeled target data. So I identify that semi-supervised domain adaptation consists of several issues such as inter- and intra-domain discrepancy, imbalance in label sample, and limitation in generating pseudo-label. So for handling above-mentioned problem, I propose a novel network architecture which includes two ZCN classifier and MLP classifier. Before I go to details of training procedures, I would like to introduce the operations of ZCN classifier. Each ZCN classifier consists of edge and node network. Edge network is to find the neighbor sample, and the node network is used for features aggregation. As shown in equation 1, the edge network explores the correlation of all samples within a batch to find the neighbor, and the neighbor information of a node is embedded in the affinity matrix as in equation 2. So then the information of affinity matrix is used for the node network aggregation as equation 3. And then I divide the training process into the three states. The first state is training on of the supervised learning. I trained MLP classifier on both label source and target data. And then I train the inter-ZCN classifier on the label source data. The node network is trained using coarse entropy nodes, and the edge network is trained using binary coarse and entropy nodes. So supervised learning process of intra-ZCN classifier is conducted similar to the inter-ZCN classifier on the label target data. So the second stage, I propose a Trico training strategy. So the first co-training strategy, I employ the coordination between MLP classifier and inter-ZCN classifier to address inter-domain discrepancy. So especially the inter-ZCN classifier provides a pseudo-label to this MLP classifier, and then the MLP classifier also provides its pseudo-label to this inter-ZCN classifier. The second co-training is implement the similar with the first co-training strategy for employ the coordination between MLP and intra-ZCN classifier to minimize intra-domain discrepancy. Thus, the third co-training strategy is proposed to alleviate the imbalance classification. I use pseudo-label generated by the inter-ZCN classifier to teach the intra-ZCN classifier, and then the pseudo-label of intra-ZCN classifier are also used for training the inter-ZCN classifier. Finally, I verify the proper methods on the challenging datasets in the domain net. As shown in this table, our results can get a high git accuracy. So we also verify the proper methods on Office Home. We also achieve the very high accuracy on this dataset. For application study, we evaluate the effectiveness of each component in the proper methods. We also verify that the ZCN classifier can provide very high quality with amounts of generated pseudo-label. And in the visualization, we demonstrate that our methods can minimize the inter and intra-domain discrepancy. We also compare the proper methods with the previous work as shown in this figure. So our proper methods can very well the alignment across domain and very clear to discriminative among of the different class. So thank you for listening.